going to look at virtual machine movement and the Hyper-V replica. So the movement, like you suggest, is just moving from host to host. Very similar to what we talked about with the vMotion. It's just called a different name. It's called live migration. And live migration, as the name suggests, it is not dead. It's running. It's being moved. So today's objective is to provide high availability and redundancy for virtualization, to implement the virtual machine movement, and to implement and manage the Hyper-V replica. The replica is a little bit different, and that's something we didn't cover in VMware because it was not part of the course. So let's talk about high availability and redundancy. Okay, so again, this is more of a review than anything because we spoke about this. So when you, once you finish setting up the system, building the infrastructure like your assignment is talking about, so you plan, you build, and everything's running, you don't make changes to your infrastructure every day. You don't make changes or redesign your network every day. You don't build new networks every day. Okay, unless that is your job, of course, unless your company is to go to every new customer and build their network for them. But if you're just working for someone like a company that has a virtualization infrastructure, you're not going to be building that every day. More likely than not, you'll get a job, and your job is to monitor the systems, to actually look at alerts, to look and respond to those alerts, to do proactive maintenance and preventative maintenance. So high availability is all about keeping the systems you got running and running well. So you might have heard of these numbers, the 5 nines, the 4 nines, and the 3 nines, whatever. That just means how much uptime. Okay, if we look at the 5 nines, which is like industry ideal, it's only 5.3 minutes per year of downtime. That includes your patches, your upgrades, and all those things that you need to restart your service for. So obviously, how do you manage that? So even if we don't go for the 5 nines and we go for the 3 nines, okay, so like for small companies such as the Airfix Confectionery, I think we can tolerate the 3 nines, even the just 99%, I think they'll be happy. That's still only if we just look at the very least one, that's only 3.7 days a year, okay? So if we turn that into hours, that's 72 hours, 0.7, that's probably another, what's that, another 14 hours. So 86 hours a year of downtime. That includes all the restarts that you need to do, all the downtime from patching and all that kind of stuff. So server downtime is unfortunately unavoidable. We all know that. Everything breaks eventually. Give it enough time, everything breaks. Servers are not always available. Software and hardware maintenance or upgrades are required. And that's probably the biggest reason for restart of your computer is that you're forced to because your system was just patched and you need to restart. There's also component failure, so power outages, natural disasters. So component failure is any part of your physical infrastructure fails. Power outages, I'm sure, like not recently, but if you've lived in SA for quite a while, then you would know that the power is not always reliable. Okay, and there's obviously natural disasters. Okay, so I think one of the reasons why we have some outages, especially depending on where you live, is some of the natural disasters as well, like bushfire. Okay, if your bushfire is down the road and it's cutting off the power or cutting off the telecommunications, then unfortunately you're offline. But we can't do much about natural disasters. We can, but we can't as well. We can if we have a lot of money. Okay, we can if we have a sort of a more than one site. We can if we have enough money to have a provisional secondary site, but it's cheaper and cheaper these days. So in the Cert Forward song, you would have learned about the cloud, AWS. Okay, so obviously what we're discussing is the private cloud, and obviously if there's a service that's only on the private cloud, how can you move it to the public cloud? Okay, so you could also have cloud as a secondary site as well. There's certain companies like Zerto, if you've never heard of them, they're like an Australian company. They're based in Western Australia, and their whole philosophy is that instead of you having a physical second site, they become your second site in the cloud. So instead of like, they're not big like AWS or Azure, but they're there for disaster recovery as your second site. So you can replica your virtual machines, your data, whatever it is, to their services off-site if you only have a single site.
And they're always in idle?
Sorry?
And they're running straight away as they need it?
Then obviously there's going to be a short switchover, okay? It's not like that, okay? There's a short switchover, but it's at least, if you have natural disaster, you might be offline for days, okay? So that second site idea is possible. So there's critical services must be constantly available. So some things are critical. Depending on your industry, some things are more critical than other things. So because I used to work on a service desk for the government, and I got this this problem, and I logged it as priority 1 because I thought it was super important, because I obviously didn't read the policies well enough, okay? But because it was a whole of government service desk, I was working for one department area, and I got told off because if it was a whole of, if I logged this job, because I was the service desk for this department, but the people I was logging this job to was the whole of government. So when I went to my department, that priority was a priority, high priority, right? But when it went to them, they told me off because they just look after like office computers or servers for the TAFE or for the offices and stuff like that. They look after the whole of the government. Can you think of anything in the whole of the government that's actually a little bit more important? Anything? Any ideas? Any systems that you might think might be a little bit more important than just your computers and your people working in office? Yeah, think of the government. So what about the hospitals? Okay. What about the ambulances? What about the fire department? What about the other places like that? So I got told off because priority 1 to them was if someone was going to lose their life, if the system's down. But the priority for my company was based on subjective to my company's needs. So therefore, that's why I got told off. So basically, like I said, some services are more important than others. So some critical service must be constantly available. Running in virtual machines, when fails or unavailable, it must be serviced elsewhere. The goal of availability or high availability is to make the service available even when there's failures or errors. All right, so redundancy in the Windows Server and Hyper-V. At the hardware layer, okay, so like we said in another presentation, at every layer there's something you can do. At the hardware layer, hey Robin, come on in. At the hardware, if it's a hardware failure, Windows hardware error architecture, reliability, availability, and serviceability. So in the hardware layer, if it's a physical server failure, we can use the live migration. For planned downtime, we can use the failover clustering. For unplanned downtime, what about for IO redundancy? So basically, again, with the redundancy, we can have network load balancing and NIC teaming. We can have the storage multipath IO, and we can use the multi-channel SMB. So really, the thing you take out of that is when you have one path, one thing, it's easy to fail, and then it's very hard to keep on going, isn't it? So we have redundant components, redundant paths, redundant servers in like multiple ways of doing the same thing, then it becomes more reliable. What about application service failure? So you can have non-clustered aware apps. You can the Hyper-V app monitoring. So for example, if you have a program that can't be clustered, doesn't have self-clustering its own, you can have Hyper-V app monitoring. So that's where the Hyper-V monitors if that program is running. What about a virtual machine guest cluster? We can use the iSCSI fiber channel, and so we all know that there's storage protocols, and we can do what's called VHDX sharing. So that means multiple virtual machines sharing the same virtual hard disk, and that's similar but not exactly the same as what we talked about with the VMware fault tolerance. Remember we were talking about that last week? There's virtual machine guest teaming. So basically, with the virtual machines, they can work as a team. So of the SRIOV NICs, which are those specialized network cards. And at the disaster recovery, we can use the Hyper-V replicas for asynchronous replication. So this is something that's a little bit more so than what we discussed in other topics because we didn't get there. It wasn't part of the course at that point in time. So what does that mean? That means that's basically really for different location. Okay, so everything we've discussed thus far is all on the same location. But you've got to understand that if you're on the one location, if you have, let's say, just someone working on the street, they have to turn off the power because they're working on the street. That means your whole site is down. If they're going to work on the street and they also need to cut your telecommunications, potentially, that means your whole site is offline. So all these things up until here is talking about individual components on the site failing and having backups, having redundancies. But this last one, which is talking about the Hyper-V replicas, that's when your whole of your site or your primary site is not available. Okay, think of the situations where, like I said, there's work going on in the street, they cut your power lines or they cut your telecommunication lines, and then there's no more connection. All about natural disasters, like we said, that if there's evacuation for this site and there's a bushfire coming through, unfortunately that your site's cut off, there's no more site. So that replica allows you to replicate the virtual machines from one site to another site. Okay, so like I said before with the company, even if you don't have a physical second site, you can also, but in our assignment there is obviously, you can pay a cloud provider such as the company I'm talking about just to host your virtual machines in the event of a second site, as a second site. So the CSV, the cluster shared volume integration with storage arrays for synchronous replication. So we can have synchronous if we use the CSV, but asynchronous with the Hyper-V replica. So synchronous means what happens here, happens here. Same time, not same time, but pretty much the same time, okay? Straight away, replicates. Asynchronous means something happens here, whatever it's going, but eventually it will get to the second site. What does that mean? It will just replicate when there's connection. It will replicate when there's changes, but there could be a situation where something's happened here and it's failed, but those replicas has not come through. So there'll be a difference in the replica. Okay, all good with that understanding? So you're probably thinking, oh, well, in that case, synchronous is best, isn't it? Of course, synchronous is best because there's no difference. But synchronous is not possible all the time because synchronous means whatever happens here must be replicated here before it can do the next thing. You see how that's happening? If you have to have synchronous replication, this cannot be can't keep on going and making changes until this has been replicated. So if you have a slow link here now, that could be a long time, couldn't it? So if it's a long time, that means this is not going to perform well because it's the The bottleneck is the connection, the slow link to the replica site. So let's talk about what we can do. So first of all, let's talk about the virtual machine move options. So virtual machine and storage migration, so we can move both the virtual machine execution, which we're used to, just where the CPU, where the RAM, where the network IOs are used. Let's leave the storage on the shared storage. Or we can move the storage and leave the execution where it is. So the storage and where it's running doesn't have to be on the same machine. If you remember, it's shared storage here, and the execution is on the Hyper-V host or the ESXi host. It doesn't matter which ESXi host, which Hyper-V host, the storage doesn't have to move, and vice versa. So there's quick migration in the Hyper-V, but this requires a failover clustering, and we'll talk more about the failover clustering later. There's live migration, which only requires network connectivity, and this is basically the same as vMotion. Okay. Improves performance in the Hyper-V, improved performance in Windows Server Hyper-V Replica. There's asynchronous replica virtual machines, and we can configure replication frequency and extend replication. We can also export and import virtual machines, which is effectively what you guys do with copying to a portable hard drive, taking it to another system, copying onto there, and then turning it off. Okay, so that's possible, but that's not really ideal, is it? So exporting we can export while the virtual machine is running. We can import the virtual machine without prior export. So if we look at how storage migration works, so this is basically we've got two storage areas. We've got the execution on the Hyper-V, and if you like to think of it, this is a shared storage. It's using the iSCSI or the fiber channel over Ethernet or fiber channel to read and write. Okay, that's what's happening here. It's reading and writing as the virtual machine is running. So first of all, read and write to the source virtual hard disk. Then secondly, the virtual hard disk is copied to the second location. But obviously this is big, isn't it? It's a big file, the virtual hard disk files. So even though it's copied, by the time it's finished copying, it would have made changes because it's still using it, isn't it? So the writes are then, after that point in time, when it's copied, the writes are mirrored. So wherever is written to the other hard disk is written here as well. And then it basically gets closer and closer and closer to being identical. And then it just switches over. After the virtual hard disk is synchronized, the virtual machine switches to the copied virtual hard disk and starts using that. So effectively, it's almost like a moment in time where it's just using that one because of that. Yeah, copying, mirroring is getting it closer and closer and closer and closer to a point where it just switches over. Okay. Theoretically, you're going to say, oh, well, it'd probably be never possible to be identical. Yes, if you're talking about physics and all that kind of stuff, yes, probably not. If we're talking about a virtual machine, there's going to be a time where it's just sitting idle, isn't it? They're not really making much changes to the system. Okay, electronically, maybe it's a little bit different, but effectively, what's written on that disk is not changing at some point in time. And that's where the switch is over. And then the existing old one is deleted, and the virtual machine it keeps on running without interruption. So this is like as if it's live migration. Okay, and look at that where it says on the back corner. It's the same as the storage vMotion. So trust me, the VMware is the leaders in the market, and Microsoft is constantly comparing to themselves to the point where even in their Microsoft slides, it's telling you that this is exactly the same as the storage vMotion. I find it very funny that one company is advertising pretty much another company's service there. So overview of the move wizard. So it's used for moving the virtual machine. So it's a wizard. You know, it's Microsoft. You start a process. It's a steps to walk you through. While the virtual machine, so moves storage while the virtual machine is running. live migration or storage migration. So live migration and storage migration are two parts. Live migration is moving the execution, so from host to another host. Storage migration is moving the virtual disk from one storage to another shared storage. Alternatively, you can use the PowerShell commandlets to use the move VM or move VM storage commandlets to do in PowerShell. Like we've been saying all along, anything you can do in the graphical user interface, you can do also with the PowerShell commands. Storage migration is enabled by default, but you can only do two at the same time. So it's very, as you can see and tell, the hard drives, virtual hard disks are very big. So if you move more than two, as you know with copying files, if you're moving multiple files, copying multiple files at the same time, it's very slow, isn't it? Whereas if you copy one file at a time, it's a lot faster than doing multiple copies at the same time. So it's limited to two at a time. Live migration must be enabled before you move the virtual machine, obviously. All virtual machine data can be moved to the same location. So that's, remember with the virtual machine, you've got virtual disks, you've got the configuration files, you've got temporary files, you've got the virtual memory files. All of them can be moved to the same location, same folder, somewhere else. Or you can move only the virtual hard disks, so you can separate them as well. Virtual machine data items, so you got the virtual hard disk, the current configuration, the checkpoints, the smart paging. So the current configuration is like if we compare it to our VMware, these are like your VMDK files, virtual hard disk files. This is like your VMX file. This is like your snapshots, which are your generated VMDK files that has those little numbers behind it. And the smart paging is your virtual memory. Remember what we talked about virtual memory previously? It's part of the hard drive that's used instead of RAM. And Microsoft calls it paging, but in this case, it's the virtual memory file. You can only move the virtual machine or also the included data items. So live migration, like I said, compares to vMotion, refers to as to share nothing, live migration. The virtual machine data can be on local. So the good thing about this one is that it can be local or SMB share, the local storage migration, move to the target virtual host first. So if you don't understand this one, if it's on the local storage, so on the Hyper-V itself, you must use the storage migration to move to a Hyper-V host that you want to go to. If it's on SMB share, so it's a shared storage, that's just Microsoft's preferred one. You can leave the data on the shared storage, which is what we used to with the vMotion. We leave it on the shared storage. We move the execution to different hosts. In both cases, the virtual machine is moved. The storage migration of virtual machine move, the storage is migrated, the virtual machine memory is moved, and the storage source storage is deleted. With the live migration, speed is affected by the virtual machine memory size and the modification, so how busy the virtual machine is. If it's very busy, its memory is constantly being modified, so you can't sort of get to that point where it's exactly the same fast enough. So that's why it takes longer. Bandwidth as well is important. Obviously, if you have a slow gigabit link between the two hosts, that's going to be a lot slower than if you had a 10 gigabit link. So if we look at this diagram, if we're talking about the live migration, this is the configuration of the virtual machine is loaded into RAM, and obviously what's stored in RAM here, and then the state. So the virtual machine memory is moved in iterations. What does iteration mean? This is first step by step. Yeah, first version, second version, third version. So each version is an iteration, okay? Source is active and can be modified, and modified memory pages are sent after the initial copy, and this repeats over newly modified pages, and finally a final copy iteration takes less than 1 TCP timeout, which means actually if you're doing continuous scan, you use one ping packet. A new MAC address is sent to the network switch, and then traffic's redirected to a new server. Okay, let's have a look. So we move the configuration, we move the contents of memory. Okay, but that one's been changed. But we'll keep on copying it, but that one's been changed, so we move the changed versions over, and then once it's the same, we change the state over to this site, or this Hyper-V server, and then this takes over. All right, so all of that so far is similar to what we already know. This is a little bit different, okay? So prerequisites for the Hyper-V replica. So like we said, the replica is where we're replicating virtual machines from one site to another site. Key thing. This protects against the whole of site outages. Okay? So with the Windows server with Hyper-V role, the Hyper-V replica is part of the Hyper-V role, and you need at least 2 servers, obviously. One to not. The more you have, the better, but you need at least 2. You need sufficient storage to host the virtual machines, local and the replicated virtual machines. Connectivity between the primary and the replica sites, so obviously there must be some connection, and the faster the connection, the better. And with the firewall rules, as with anything, if you don't allow the firewall traffic, then that replication traffic won't be allowed. So we need to allow the Hyper-V replica HTTP and HTTPS. It uses that X.509v3 certificate for mutual authentication. Obviously, if you're replicating with someone, what if there is, hey, I'm your friend, send me all your replicas. Remember, that's like a man-in-the-middle attack, isn't it? So if they don't, so what happens in the man-in-the-middle is you give it to someone without checking if they are who they are. But we both need to know, what if someone is trying to give you information and it's like you're accepting wrong information from someone who's an attacker, right? So you need to check who you're getting information from and also who you're giving information from too. So mutual authentication is where I prove who I am to you, you prove who you are to me, and then once we're happy with that, then we can do the exchange. So it uses that certificate for mutual authentication if the certificate authentication is used. Otherwise, Hyper-V host must be in the same Active Directory domain, then there's a trust. So Hyper-V replicas has the following components. You need a replication engine, which manages replication configuration and handles the initial replication. That initial replication is important because initial is the first time. Usually virtual machines are quite big. So the first time is a big replication. Afterwards, it's not so big, it's just changes. Delta replication. Have you heard of the term deltas before? No? What about you, son? Alexa, you heard of the term delta?
I heard in math.
Yeah, I know. What does it mean in maths?
Just a Greek.
I know, it's a Greek letter, I know, but in science, in maths, and in engineering, delta means difference. Okay? Yeah, delta speed over delta time equals whatever, right? That's usually part of the thing. Delta means difference. So basically, the first one is a big file because there's nothing over there. So big transfer. But after the initial transfer, anything else, any other replication is just delta replication, which means changes, differences. Okay? So basically, the initial replication, if we send over a slow link, it can take ages, right? It can take a long time. So with that initial replication, we can actually go replicate to this hard drive. Okay. Then I physically drive to Elizabeth. Now, see from this hard drive to the server. You get me? So you can do that initial replication maybe possibly a lot quicker if you physically take a hard drive from this side to the other side just by driving, depending how big the data is. But then after that, it's delta replications, like it says. Delta means just the differences. Most times the difference is not huge, and it's obviously replicated. It can be configured as failover and test failover. What does that mean? Failover, obviously one side's down, those same virtual machines exist at the second site, and then they get turned on and they take over. They take over the functions. We can also do what's called a test failover, which means we're just testing the infrastructure to see if it's possible without actually changing where the service is being provided. So what happens with the test failover is that that virtual machine is just turned on over on the second site, but it does not switch over. Okay. We can also change tracking modules. So obviously we need to know if there's been changes. Keeps track of the write and operations of the virtual machine. And there's a network module which provides a secure, efficient channel to transfer data. There's a Hyper-V Replica broker server role, which provides seamless replication while the virtual machine is running and on a different failover cluster node. The management tools that we do this with is the Hyper-V Manager, the PowerShell, or the Failover Cluster Manager. So if we have a picture of what it looks like, we have primary site. Let's say if we're talking about our scenario, FS Confectionery LA site. We have a secondary site. In this case, if we look at our scenario, it could be the Elizabeth site. We have hosts on both sides. We have shared storage on both sides. Okay. We have virtual machine running on the primary site. There's some key ones, potentially, some key virtual machines. Obviously, there might be some virtual machines on the secondary site as well, but these are the ones we're talking about, are the key ones, the ones that we want to protect. So these virtual machines have been replicated. The initial replication can take quite a bit of time, but then after that it's the delta replications which are relatively small. If it's a failover situation where the third primary site goes offline because someone's dug up the cables, all gone off. It detects it because there's no more replications. If there's no more replications for a certain amount of time, it will detect that the primary site has failed and it goes into failover, which means these virtual machines over here gets turned on and takes over the functionality. So like I said previously, if we fail over from virtual machine from one site to the other site, replication is enabled per virtual machine, so we don't have to enable it for every virtual machine. We just choose the ones we want to protect. And with the replication wizard, the replica server connection, we have connection parameters. We choose the replication virtual hard disks. We choose how frequent, so we can do it very frequent, or just every 15 minutes, or something longer. But obviously, every 5 minutes or something like that. I think that's one of the settings. The more frequent it is, the less likely that your primary site and secondary site is different. More likely they're the same. So if there's a failover, it means you'd lose nothing or lose very little. But the problem is, if you're doing replicates all the time, it just consumes more bandwidth, consumes more networking resources. But if you leave it too long, that means if there's a failure, it could be data that's not replicated. We can configure additional recovery points. So these recovery points are basically almost like snapshots. And we can also choose how the initial replication method is taken. Obviously, if we talk about our primary site and our secondary site, there's going to be different network or different subnet, right? So how can your virtual machine go over there and work straight away? So we can configure what's called TCP/IP failover settings, which basically pre-configures an IP address for the replica virtual machines, and obviously when it's a failover, it takes on this failover setting instead of the original settings. And this requires the integration services. If you remember what the integration services is, like the VMware tools of Hyper-V. It should be configured on both the primary and the replica service. So obviously, if we don't have software-defined networking, we can't just have our IP address that exists on this subnet and then replica over here and turn on and expect it to work. So this failover TCP/IP settings means that it uses this IP address while it's at the primary site, but it uses this IP address if it's failed over to the secondary site. Well, we can monitor the health of the replica. So obviously normal is good. That means less than 20% of the replication cycles are missed. Sometimes some things just happen. You miss a little bit here and there. but that's okay if it's within less than 20%. And also the last synchronization point was less than an hour ago, and the average latency is below the configured limit. You get into a warning state if greater than 20% of the replication cycles have been missed. More than an hour since the last replica, initial replication has not been completed, or the failover has been initiated, but the reverse replication has not been configured. So what does that mean, reverse replication? So if you're at the primary site, you replicate to the secondary site, and if there's a failover, the secondary site takes over. So all the changes have been happening here now. But what happens when the primary site comes back online? All the changes have been happening here. Does the virtual machines over here suddenly takes over again? Or you can't unless the changes here has been replicated back to the primary site. So you get a warning if the reverse replication has not been configured or has not happened yet. Or the primary virtual machine replication is paused. You get critical errors if the replica pause on the replica virtual machine, or the primary server is unable to send the replicated data. So this tells you how it's going. Like I said, you can test the failover without actually failing over. Test failover is a non-disruptive way to test with zero downtime, so you don't do anything with the existing virtual machines. They're still running, they're doing their job, but the new virtual machine is created at the recovery site, and it can be from a checkpoint, and it's actually just turned off. So you can see it created, but it's not doing anything. And then we can stop the test failover. We can also do what's called a planned failover. This is interesting. What does that mean? It means that, hey, you got an email to say that next Saturday on your street, people are going to work on power lines. So there'll be their power outage for about 3 hours from Saturday 1 p.m. to 4 p.m. So if you know that 1 week in advance, you shouldn't have any downtime, should you? Okay, what you can do now is actually, you have that second site, you have a replica going. We can actually say at, Saturday, if it's 1 p.m., maybe at 10 a.m., we do a planned failover, which means we initiate a primary virtual machine, which is initiated a primary virtual machine. So we basically say failover now. So it turns off the primary virtual machine, sends the data that has not been replicated, and then fails over to the second site. So there'll be momentary downtime, but there's no lost data. Then we start the replica virtual machine, and then the reverse replication is configured after the primary site comes back online. Or we can just fail over. Failover is where there's no warning. Something just happens. It realizes there's not been replication for ages. So basically initiated the replica virtual machine at the replica site, detected there's no replication, the primary virtual machine has failed or turned off, or it's unreliable. The data loss can occur because there's no warning. Did the last thing replicate? No, maybe it didn't. So there could be some data loss. Then we fail over to the replica, and the reverse replication after the primary site comes back online. Some other replication-related actions, you can pause replication. Okay, maybe you just want to do something, so you don't want it to accidentally fail over, because obviously that might not be the intention, so we can actually just pause it. We can view the replication health, we can extend replication, we can remove recovery points. Recovery points are basically snapshots almost of certain points that you want to keep, and we can basically remove replication as well. So this virtual machine is no longer important, so we don't want it to be replicated. So replica resynchronization, when normal replication process is interrupted, change tracking issues on the primary server, replication issues with tracking log, or problems linking the virtual machine hard disk with the parent, or it's being time traveled, so maybe it's been restored to a backup, or the reverse replication after the failover process. These are all problems that causes resynchronization. The processor storage and network, process storage and network intensive. It's configured on the primary virtual machine. We can manually, automatically, or at a scheduled time resynchronize. If more than 6 hours, we'll need to perform a initial replication. So remember that initial replication is very large. So if there's a problem with replication, and if it's more than 6 hours, you probably need to do a full initial replication again.